This is 1, 1. Oh, I need a color we can see. Oh. Graphing. Quadratic. So I guess my first question to you would be, do you know what a quadratic is?
Something that has four.
That would be what would make sense, right? But unfortunately, that's not like that quadratic is. Does anybody know what a quadratic is?
I'll learn it last year.
Yeah, something to do with four. Something with four.
How about, let me ask this. Does anybody know what it looks like when we graph a quadratic? What is that called? It's a parabola. That's exactly right. So when we graph a quadratic, we get a parabola. It looks like this, or maybe I'm not an artist by any stretch of the imagination, or it could be upside down. And it could be wider, it could be skinnier, up, down. We're going to talk about all those characteristics. So the equation we use to graph, you know, you've graphed lines, right?
Yeah.
Slope, intercept, point, slope, all those good ways to graph lines. And so we have standard form of a quadratic, and it looks like this. Now that's a lot of variables, right? But the A, the B, and the C are actually just coefficients. A, B. Actually, I shouldn't say C is a coefficient. C is a constant there on the end. But what I'm getting at is if you had, let's say, y equals 2x squared plus 3x minus 1. In this case, A is 2, B is 3, and C is negative 1, right? So we're taking the coefficients off, the variables are not part of that. So what makes it a quadratic is this little exponent here that's squared. Okay, the biggest exponent in it is a 2. That makes it a quadratic. If I go too fast, which I often do, please slow me down, tell me to stop, and I'll stop. Or if you have a question, stop me, okay? I don't want you to be so frantically writing that you don't. So before we actually graph, let me run through some characteristics of a quadratic, of a parabola. Let's look at one. We'll do one that opens up. Most important point on a parabola, where do you think it happens? The middle. I hear the middle, the center, down, the bottom. Does anybody know what that's called?
The bottom.
That's what it looks like.
It's a minimum. It's a minimum value because it's the lowest value. But does anybody know the terminology we use there, the vocabulary word? It starts with a V.
Vortex.
Close. Change the O to an E. It's a vertex. Yes.
Yes, I got it.
So, and several of you recognize right off the bat that this is a lowest point, and that's very important because when it's opening up like that, this is a minimum. Minimum. Okay? Now, if it opened the other way, it would be a what? A maximum, right? If it did this, then that vertex is still a vertex, but that vertex becomes a maximum. What else do you think is special other than being the lowest point right there? What else do you think? And think in terms of geometry. What else do you think? Who said it? Good job. It splits it. There is a line of symmetry through the vertex. Parabolas are symmetric. That was awesome. Miss Wilson will be proud. No, don't do that. So there is a line of symmetry through the vertex. We call this on a parabola the axis of symmetry. And if you remember what it means to be symmetric, that means each point on this side is reflected over that line the same place on the other. Okay? All right, so we got maximums or minimums depending on which way it opens. We've got the axis of symmetry. Let's talk about how the equation impacts this. And I know I'm doing a lot before we actually graph it, but I want you to kind of have an idea. So let's go back to that standard form, that ax squared plus bx plus c. You know everything means something when you're graphing a line and it's mx plus b. The m is the what? Slope. The b is the what? Y-intercept. So same kind of concept here. These as these values start to vary, it's going to impact the shape and the way that our parabola looks. So let's look at the A first. A is very important. It tells us two things. The first thing it tells us is if A is positive, then our parabola is going to open up. Remember I told you it could go up or it could go down? If it's positive, it's going to go up. What do you think that leaves us if it's negative? Y'all are so smart. Negative goes down. So it goes down. Easy enough so far?
Yes, ma'am.
Thank you for that. Okay. Positive up, negative down. I told you, though, that it tells you two things. So it tells you if it goes up or down. It also tells you how skinny or wide the graph is going to be. And this is where it gets a little bit tricky. Not looking at positive or negative, so taking the absolute value of the front. When A is 1, that's an average graph. Okay? And we'll talk about what average looks like, but that's kind of where we start from. The bigger A gets, so as A gets bigger than 1, the graph actually gets skinnier. So if I had y equals 10x squared, it's going to be an itty bitty skinny graph as compared to y equals 2x squared. The bigger it gets, the skinnier it gets. Does that make sense? So then the smaller it gets, but remember absolute values, so not negative. So I'm going to say absolute value of A less than 1. So what kind of numbers am I talking about? No negatives. Decimals, fractions, anything less than 1 but not crossing over to the negative side. Negative tells me up or down. It gets wider. So if I had 1/4 x squared, that's a wide graph. Make sense so far? Okay, we'll do several examples and it'll all come together. The last thing I want to tell you about the equation is the C. That C is my constant on the end. It is also my Y-intercept, just like the B is in slope-intercept form. Everybody okay? Y'all sleepy after lunch? Mm-hmm. Some of y'all look kind of sleepy. Don't worry, the air will kick on and wake everybody up. All right, we okay so far?
Yes, ma'am.
Okay, thank you for that. I appreciate the enthusiasm. This. Let me give you a couple of, what's up, crap? Domain range?
Huh?
What?
Like, because examples. Like, I'm so confused right now.
Oh, that's okay. It's going to come together. I am going to give you a couple equations. We're not graphing yet. I want us to kind of analyze together what this is going to look like before we actually graph it.
It's a wide graph.
Oh, good job. How do you know? Awesome. Okay. So the first one we've already determined was wide, but let's run through everything we know. First of all, sometimes it helps if you identify A, B, and C before you start. So looking at that first example, tell me what is A? 1/2. What is B? -5. What is C? Does that graph open up or down? Why? It's positive in front, which means it's going to open up. Skinny, wide, or average? Wide, because the smaller this number gets, the more it stretches the graph out. Does that make sense to everybody?
Yes, ma'am.
Thank you. How about Y-intercept? It's 3. So it's crossing the y-axis at 3. So I don't know anything else about this graph, but I know it's going up. I know it's going to be wider than average, and I know it's going to have a y-intercept of 3. Everybody sees where we got those numbers? Yes, ma'am.
So what do we do with the number?
We're going to use that to find vertex in just a minute. I'm sorry. We'll get there. That's okay. Look at the second one. What's A? How about B?
0.
Ooh, good job. Good catch, guys. 0. It's not there since 0. How about C?
5.
-5. Up or down? Down. Why? It's a negative, so it goes down. How about skinny, wide, or average? Skinny. That 2 is getting bigger than 1, so it's going to shrink it in. How about the Y-intercept? Negative. Somebody said it quietly. -5. Last one, a little bit trickier. What is A? Good job. 1. This time in the difference is the variable is actually there. The x squared is there, so there's an imaginary 1 in front. Whereas on the second one, the whole term was missing, so it's 0. Do y'all see the difference in that? How about B? 2. Good job. And C? 0. Okay. Well, so we look at the absolute value of this number because the positive or negative tells us if it's up or down. So the absolute value of -2 is 2. So is 2 bigger than 1 or smaller than 1? Bigger. So the bigger it is, the skinnier it is. Just ignore the negative when you're talking about skinny or wide. Up or down on the last one? Up. Skinny, wide, or average? Average because it's 1. That's going to be what I compare everything to is a 1. Y-intercept?
0.
Good job. Who's confused? Don't be ashamed if you're confused now. Okay, where'd I lose you?
How's it average?
If the A is ever 1, that's always an average one. And then as it gets bigger, it's skinnier, smaller, it's wider. Other questions? We okay? Okay, let's talk about the vertex. I told you the most important part was the vertex. The most important point on that parabola is the vertex, so I need to tell you how to find it. And then we're going to put all this together and actually graph them. All right, so we've got this equation. Ax squared plus bx plus c. To find that vertex, first thing we're going to do is find the x part. And by finding the x part, if you think about if the axis of symmetry is if this is my parabola, my vertex is going to be xy, right? It's got 2 parts. It's got an x and a y. The equation of this line, a vertical line, is in the form x equals, right? That's a vertical line. So this is going to give me my axis of symmetry by finding x. Does that make sense? Okay. I see y'all going, yeah, okay. So what I'm going to do is use this little formula to find the x part. I'm going to do opposite b over 2a. Notice I didn't say negative b, I said opposite b. Why do you think I said opposite, not negative? If it's already a negative negative makes a positive. So just to save confusion, whatever the sign is, you lost. So this is also my axis of symmetry. Now before I do an example of this with you, if I have the x part of the vertex, I told you it has 2 parts, it has an x and a y. How in the world do I find the y part? If you have an equation that you're graphing, what do? You plug it back in here, right? So I'm going to find this, and then I'm going to plug it back in that equation. I'm going to say y equals plug in. And we'll do an example. Y'all seem bored. Are y'all bored?
I think this is our
I think when you see it pulled all together, it'll make sense. I'm kind of trying to give it to you a piece at a time and then put it all together.
That's what this listener said, and I'm still confused past part.
All right, y'all got that part? I'm gonna take that as a yes.
Oh, yeah.
Let's say I have y equals 2x squared minus 3x plus 1. Before we graph it, tell me what you know about it.
It's going to be.
It's going to be skinny. What else do you know? And up. What else do you know?
Y-intercept is 1.
Y-intercept is 1. Let's find the vertex, shall we? Yes, we shall. So remember, we're going to do opposite b over 2a. What is b? Negative 3. So what's opposite b? 3. What a terrible first example I picked. Yuck. Okay, well, we're going with it now. Over 2a. So 2, what is a? 2. So the x part of the vertex is 3/4. I told y'all this is a horrible one. Which means, here's 1. My axis of symmetry is going to be at like 3/4.
Okay, yeah, that one.
Well, but all of yours aren't going to be nice and even, so we might as well hit it now. What? So I would assume you're going to probably need your calculator at this point when we plug in to find y. If you have one with you.
I have 2.
And I'm plugging back in because somebody said, how do you find out where on this dashed line you go? Well, you have to plug into the equation. The equation tells you y equals this. So to find out, I have to use that to plug in.
Oh, okay, so you have to find x and then you have to find y and then that's.
Absolutely, and those are your coordinates.
Yeah.
Minus 3 times 3/4 plus 1. If you have your calculator, let's do this together, shall we? Somebody's going to have to call that out to me. Come on. You can do it. The equation, so I can plug it in here. And I'm going to show you how to convert it over and everything. Well, it was 2 times 3/4. We all know how to enter fractions on our calculators, right?
Yeah.
Squared minus
3 times 3.
So if you hit math, enter, you'll get the fraction back out, so it's negative 1/8. Math, the button that says math under the alpha buttons. Math, and then the very first option there is fraction, and it says convert whatever I have back into a fraction for me. So you don't have to go through all the common denominators and everything else as you add and subtract. All right, so I've got negative 1/8 when I plug that in, which means the vertex of this, we said it's up, we said it's skinny, we said the y-intercept is 1. The vertex, the coordinates of the vertex would be 3/4, negative 1/8. So down just a smidge. Does that make sense? Does it make dollars? I'm sorry. I'll pause it next time. I want one as hard as mine. I'll give you one a little bit easier for your first time. Let's do. I want you to find the vertex. Opposite B over 2A. What is B?
0.
0. What is A?
1/2.
I can't really do the negative 0, so I leave it. It doesn't really even matter what's on the bottom because 0 divided by anything is 0. Plug it back in. 1/2 times 0 squared. Exponents come first, so 0 squared is 0. Times 1/2 is 0. Plus 3 is 3. What are the coordinates of my vertex? 0. Before we move on and graph, give me a thumbs. I can find the vertex of any equation you give me. I'm so on it, I can't do it at all. Okay. 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 So when we graph, when it's in standard form, and there are other forms, we'll learn about 3 different forms. You know how you graph a line? There's different forms it can be. It can be in standard form, slope, intercept form, point slope. Same thing with quadratics, and so there's different ways we graph it. So standard form is probably the most involved way to graph, but it's the way that you can always go back and graph into. So it's good to know, be most familiar with this form. First thing we want to do is find that most important point, which is the what? The vertex. All right, so I want to find, tell me how I find the vertex. How? What's the formula?
X equals the opposite of B over 2.
Now that's half of my vertex. And then you plug it in, right? So I'm going to put plug in to find y. So step over to the example on the right side. If I find the vertex here, what is the x part? Let's plug in. Or not what is the x part? Let's plug in. What goes on top?
8.
8, because it's negative 8 here, so I'm going to do opposite b. So 8 over
2
times 2. Because it's 2a. So 8 over 4, I hope you can do that in your head, gives me 2. Now I'm going to flip over, and I'm going to put a graph on here so I can show you, and I'll come right back to that. Let me pause. So that x part is also my axis of symmetry, so at 2, can y'all see that color? Okay, on 2 is where my axis of symmetry is going to be. I don't know where up or down that vertex is actually going to land, but I know it's going to land somewhere on that dotted line. So let's flip back here. How do I find where it's going to land? Plug it in. So y equals 2 times 2 squared minus 8 times 2 plus 6. Exponents first, so 2 squared is times 2 is 8. So I have 8 minus, that's right, plus 6. Now move left to right. 8 minus 16 is, plus 6 is negative 2. Am I going too fast for anybody? Sure? Kind of fly through some of the arithmetic part, so I want to make sure we're all good. So what are the actual coordinates of my vertex?
2, negative 2.
2, negative 2. On that dotted line, I'm going to go down to 2, and that's where my vertex is going to sit. -2, there's my vertex. Everybody okay on that? I hope it's starting to come together a little bit for you. We took it in pieces. So now a little bit of new part. I need another point. It really does not matter what point you use. And I'm going to do a couple to show you. I'm going to say we need find an easy point. And I say that because you can pick any x that you want when you do this. But the smart thing is going to be to stay close to the vertex. Because if you think about how that parabola does, if I'm right here and this is 2, it goes up really fast the further. What if I pick 10? 10's way over here. Look how high up that's going to go. It's going to start moving fast. So I want to stay real close to this area, real close to this 2. So maybe I pick what? 3. Or 1. Something close, right? You can also choose the Y-intercept if it's small enough. This one's small enough, I could probably plot a 6 and use it. So either of those would work. When I say easy points, I want to make sure that you're picking something that's easy for you to work with. So let's do one that we have to plug in here. Let's do, I'm going to do 1. 1 seems to be an easy number to work with. 1 or 3, because those are right beside here, not the 2. I would prefer to use a 1. So let's plug in, right? That's how we find the other half, is we plug in. I shouldn't say x equals 1. I should say close to the vertex. And I chose 1 here, and it's not always going to be 1. It could be just whatever's close to the vertex. When I plug in 2 times 1 squared minus 8 times 1 plus 6. Am I moving too fast? Need me to stop a second? Everybody okay? Y'all gotta talk to me. Thank you. Exponents first, so 1 squared is 1 times 2 is 2 minus plus 6. Left to right, 2 minus 8 is plus 6 is, what are the coordinates of my easy point here? 1, 0. I'm going to give you just a second. All right, 1, 0. Just thinking about it. There it goes. 1, 0. Now we're almost there, because in order to graph a good parabola, I need 3 points. I have the vertex. Here's my easy point, bless you. Now I need another. So taking what you know about parabolas, how might I find another point easily on this parabola? Reflect it. I call this step reflect and connect. Reflect it over that axis you already have drawn. Make Miss Wilson proud that you remember how to reflect a point over a line. Right? So the very last step is going to be, why am I not going down here? There we go. Reflect and connect. Boy, this thing is slow today. Here we go. So if this is my point and this is my line of reflection, count over to that line and then keep going over that many again. Make sure you've marked your vertex so you know which one's the vertex. You're not trying to reflect the vertex. And connect them. Just make sure this is rounded here and not a V, but you're good to go. Tell me what you think. Graphing in standard form. It's not bad.
I like this one.
Good. Good. One more together. It won't take as long as the first one. The first one takes a long time because I'm running through steps with you. Once you know the steps, it's not as bad. Let's do one more together. One more together, and then I'll let you start on your homework in class. How about that? Let's do... Ooh, here's a good question. Looking at this parabola, does it have a maximum or a minimum value?
Minimum.
A minimum. If I just gave you the equation, could you tell me if it had a maximum or minimum?
Probably not.
I bet you could. How could you tell?
Oh, yeah.
If it goes up, it has a what?
Minimum.
A minimum, and if it goes down, it has a maximum. Okay. All right, let's graph this one. Why don't you try this in your group, and then we'll do it together. Let's do Oh, by the way, if you see it written like this, what does that mean?
Y.
Same thing as y. It means it's a function of x.
I hate it.
Oh my gosh, it's a fraction. What? Try to graph it. All right, find the vertex first.
Okay, we gotta do the vertex.
So x is opposite b. What is b? 0 over 2a, and it really doesn't matter as long as the bottom's not 0 and it's not, so it's 0, right?
Yeah.
I need to find the other half because all that's giving me is my axis of symmetry, which is actually on the y-axis. So plug it in, yes?
Yeah.
1/4 times 0 squared plus 2. 0 squared is 0, times 1/4 is 0, plus 2 is... Did everyone get 0, 2 for your vertex? Yay! Give yourself a pat on the back. That's awesome. That's the hardest part. I need an easy point. 1. That's close to the vertex. That will work. I gave you this one intentionally because I told you sometimes you could use that Y-intercept. And in this case, the Y-intercept doesn't work for your easy point because it's already being used as the vertex. Okay? So we need to pick another one. So we're going to do 1. I think that's a wonderful choice. And when we plug it in, 1/4 times 1 squared plus 2. 1 squared is, times 1/4 is 1/4, plus 2 is 2 and 1/4, which we don't like mixed numbers like that, so we make that 9/4. But if you let, it really doesn't matter. All right, 1 up a little bit past 2. I'm not getting a ruler out and making sure you went up exactly 1/4 of a unit on your graph by any stretch of the imagination. No, we're not doing that here. I just don't have time to do that there. So reflect and connect. Reflect, connect. Notice it is getting wider because of that 1/4. And if I'd have really only gone up 1/4, you'd have really seen it getting wider. It's up because it's positive, and yes, the y-intercept is 2, so I'm going to get that. Woo! Tell me what you think.
I think